Okay, in this video I'm going to demonstrate a binary logistic regression using SPSS. Binary logistic regression is utilized when you have a dependent variable that is dichotomous, and the levels of that variable essentially represent membership in one of two groups. So essentially the group membership should be mutually exclusive, and so we're essentially going to be trying to predict group membership based on a set of predictors. So in this data set that I have open, you'll notice that I've got a variable called donate, gender, and some other variables here. Essentially what I was doing with this data set, I have participant responses to a question where they were asked, do you intend to donate to a political cause in the future, where 0 was reflected in intention not to donate, 1 reflecting an intention to donate. We also have gender coded 0 for male and 1 for female. We have a measure of political interest, dogmatism, external political efficacy, and consideration of future consequences. So all of these variables are being treated as scale variables because we're assuming them to be essentially continuous. So there are two ways in which we can run a binary logistic regression through SPSS menu system. So I'll show both of these really quickly. So if we go to Analyze Regression and then go down to Binary Logistic, we'll move Donate over to the dependent box, and we'll move Gender, political interest, and dogmatism over to the covariates box. Now, gender technically is a nominal variable, but given that it is dummy coded, we can essentially treat it as a scale variable in the context of our logistic regression. If we happen to have a variable that is nominal or ordinal and contains more than 2 levels, then we would need to dummy code that variable, or create a set of dummy variables to represent group membership, and we could still include those dummy variables as covariates in this model, but we would have to use dummy coding to include them for our analysis. I'm going to go to Options, and under Hosmer-Levy-Show Goodness of Fit Test, I'm going to click on that, and the confidence interval for the odds ratio. Click on Continue and then on OK, and so our output, when we look at it, you'll notice that we get output. The first set of output is for a beginning block, which is largely irrelevant. I don't know why it's actually included. Essentially, this is reflecting a model that includes no predictors in it. So it's not terribly useful. What we want to pay attention to is block 1, where we've entered our predictor variables. So essentially, this model up here is a null model with no predictors, and then this model is essentially a full model that includes our predictors. So you'll notice, first of all, that you have a table where it's got step, block, and model. And really, because we've simultaneously entered all of our predictors, all of these chi-square values and significance, all that's going to be exactly the same at each step. So really, you probably just want to go ahead and just pay attention to, you can just look at the model chi-square. And what this is essentially reflecting, and really all of these is reflecting, is a test of whether our model that includes our full set of predictors, if that is a significant improvement in fit over the null model that we saw up here. And so if the chi-square test is statistically significant, which in this case we see that it is, then that indicates that that our full model is a significant improvement in fit over the null model. You'll notice too, under model summary, these are various pseudo R-square values. So these are a little trickier to interpret because of the pseudo nature of them, I guess you could say. They aren't computed in the same way that we compute R-square in the context of least squares regression. And so really we sort of interpret these through reasoning, I guess you could say reasoning by analogy more than anything else. But these aren't technically the proportion of variation in the dependent variable accounted for by the predictors. So like I said, they tend to be a little tricky to interpret. There's even a question as to whether they're even useful to rely on. But nevertheless, one thing to note is if you are going to rely on them, I tend to prefer the Nagelkerke R-square because it has a range from 0 to 1, whereas the Cox and Snell R-square, the upper bound doesn't actually reach 1. And so, again, if I want to be as closely analogous to the R-square that we have in least squares regression, at least in my opinion, this seems to be the more logical choice. Okay, we also have the Hosmer-Lehmann-Show test, and this is a chi-square test as well, and there's our p-value for it. Now, unlike the chi-square test that we have up here, in this case, we're sort of seeking significance in order to reject a null hypothesis, the null being that the models are fitting equally well. So if we reject the null hypothesis, then what we're saying is that our full model is fitting better than or significantly better than the null model. If it's not significant, then we're essentially going to conclude that our full model does not represent a significant improvement in fit. Now, when it comes to interpreting the Hosmer-Lehmann-Show test, we use sort of a different way of thinking. In this case, we're actually testing the fit of our model, but using non-significance as an indicator of goodness of fit. So if our p-value right here is indicating non-significance, which it is, then that's actually indicative of a good fit. So that's a good fitting model. And so really we have, up here, this test right here and this test right here, both are pretty much telling us the same story in terms of the fit of our model to the data. So if we scroll down a little bit further, we get a classification table. And so here you can see that we have, this is essentially plotting or pitting the observed data against predicted values in terms of group memberships. So observed group memberships pitted against predicted memberships based on our logistic regression model. So essentially, as you're looking at this, you have to kind of think in terms of if we look at this diagonal right here, then what that's conveying are the hits within the model. So in other words, we have correspondence between the observed group membership and the memberships that are predicted based on the model. On the off diagonal, or I guess you'd say the other diagonal, you would have essentially misses for the model. And so these are misclassifications based on our logistic regression model. So you can see right here that the value, the 0 right here is reflecting, for the observed variable, donate variable, 0 is reflecting lack of intention or non-intention to, or intention not to donate. 1's reflecting intention to donate. So we can see that we have a total of 134 cases. If we add this number and this number together, that's 134 cases that were observed in the data to indicate intention not to donate. And 129 of those, of that 134, were correctly predicted by the model to express an intention not to donate. So that means that we have an accuracy rate of about 96% when it comes to predicting those who intend not to donate. So that's pretty good. Whereas when we look at those intending to donate, essentially if we add the 29 and 12, we end up with 41 persons who did express an intention to donate to a political cause, but only 12 were correctly predicted by the model to express that intention. So we have an accuracy rate of 29.3%. So, and then if we look at the overall classification accuracy, we had roughly 81% of our sample were correctly predicted to fall into their respective groups. But nevertheless, so this overall, this is a pretty good classification rate, but you can see that it's we're not doing the same job in terms of accuracy between the two groups. So we do a good job of predicting, based on the model, we do a good job of predicting who won't or who intend not to donate, but we do a lousy job of predicting those who express an intention to donate. So kind of moving down, you can see our variables in the equation. So we've got, you know, some of our output is indicating that we have good overall fit, and we also want to look at the fit within the model in terms of the individual predictors. So you can see that we have gender, political interest, and dogmatism. These are our predictors, and these are the regression weights for the model. And the thing about it is, oh yeah, and before I even continue with that, just note that these are the regression weights, the standard errors. If we take the ratio of the regression weights to standard errors, we get a Wald z-value, and then we have you know, our significance levels for those. This right here, this is referring to an odds ratio, and I'll kind of get to that in a minute. So the important thing to note, in the context of least squares regression, when we look at the regression coefficients, what that's telling us is the predicted amount of change on our dependent variable in raw score units for every 1 unit increase on the predictor variable. And so the thing is that the unstandardized regression coefficient in least squares regression is expressing change in raw score units. In the context of logistic regression, we have a dichotomous dependent variable, so we can't really talk about predicted change in any kind of raw score metric or anything like that. What we're really keying in on is essentially the predicted probability of falling into a target group. So you kind of have to think about it this way, that we have our two groups. We have group coded 1 and 0. 1 was our intention to donate group, and 0 being the not intending to donate group. Now, so we're really kind of keying in on the probability of of falling into the intend to donate group. Now, the way that we study the predicted, the relationship between the predictors and our dependent variable is that we kind of operate through a concept through sort of intermediate concepts which are called odds and log odds. So here's the thing, that we can't really look at the relationship between our predictors and probabilities of falling into the target group because essentially that's a nonlinear relationship. And what we want to do is to be able to study the relationship between our predictors and our dependent variable using a linear equation. And so essentially what we end up doing is modeling that relationship and through the concept of log odds. Okay, and so let me kind of walk you through what some of this stuff means. So the basic idea is that, and so just really quickly, so essentially what we're doing right here is we're talking about the predicted change in log odds for every 1 unit increase on our predictor variables. So that's essentially what the interpretation of these coefficients is reflecting. Now, this is wholly counterintuitive, and many people kind of get bothered by the fact that we're talking about log odds instead of just the probabilities and so forth. But like I said, we can't really model the relationship between these predictor variables and the probabilities of target group membership directly because that relationship is nonlinear. And so we essentially are able to make that relationship linear through converting our probabilities to log odds. So the way that this works is that we'll take our intervening step looking at odds. And so odds are basically a ratio of probabilities. So we essentially have the probability, it's essentially a ratio of the probability of event A to the probability of event B. Okay, so in the context of our study, we're going to use our target group is going to be the intention to donate group, and our non-target group is the not intending to donate group. So in other words, we can form an odds for each case in terms of a ratio of the probability of that case falling into a target group, which is the intention to donate, over the ratio, the probability of not falling into that group. So essentially, it's just basically the P, T over, P, we'll say not T. Okay, so that's essentially what odds are. And so log odds essentially is just taking the natural log of the odds. So that's all that's taking place. And so by doing this, what we end up with is essentially sort of an indirect way of getting at the probability of membership in the target group that is now linearly related to the predictor variables. So all this is to say that, when you're looking at these coefficients, we're not really talking about the, change in probability or even the change in odds of target group membership for every 1 unit increase. It's the change in log odds. But nevertheless, what we're essentially capturing is changing probabilities, kind of indirectly through this vehicle here. So you can see that this coefficient is negative, and based on our coding system, we had 0 for male, 1 for female. So the fact that this coefficient is negative is indicating that males were demonstrating a greater likelihood of expressing an intention to donate than females, but that difference was not statistically significant. When you look at political interest, we have a positive coefficient, and it's statistically significant. And this is indicating that persons who are falling into the persons who tended to be higher in political interest also tended to be more likely to express an intention to donate. Those who were lower in political interest were less likely to express an intention to donate. So notice the language. I'm talking about the intention to donate group as my target group. For dogmatism, there's a positive coefficient here. It's not significant. I pretty much would have been inclined to think that, if you're more dogmatic or certain about your beliefs, you might be more inclined to express a greater intention to donate in order to support those beliefs, which might then legitimize a one-tailed test instead of a two-tailed test, which these p-values are all for two-tailed tests. It was positive, and so we could say that persons who tended to exhibit more dogmatic attitudes tended to be more likely to express an intention to donate than those who were lower in dogmatic attitudes. So that's kind of how you can think about it. So just keep in mind again that when we're talking about the actual predicted values, we're really talking about the predicted log odds, but we can sort of use that as sort of a indirect way of really kind of reflecting increasing and decreasing probabilities of target group membership. You'll notice this column right here. It's the this is basically referred to as an odds ratio, and previously when I was describing the odds, I was giving you a ratio of probability. So probability of A in relation to probability of B. The odds ratio that you see right here is actually reflecting the change in odds for every unit increment on our predictor variables. So in other words, you could think about it this way, that essentially the odds at a given level on a predictor variable are multiplied by this factor right here, as we increase from one level to another on our predictor variable. So the odds ratio is literally a ratio of odds. So that's the way to think about it. So just kind of looking at odds and odds ratios, let me just kind of say this too, that using in the context of odds, if we have the probability of falling into the target group being equivalent to the probability of falling into the non-target group, we would expect an odds that's equal to 1. If the probability of falling into the target group is greater than the probability of falling into the non-target group, then we would expect the odds to be greater than 1. And then if the probability of target membership is less than the probability of non-target membership, then we would expect the odds to be less than 1. So just kind of keep that in mind as you are thinking about the concept of odds. So with odds ratios, we use kind of the same general idea, which is that if the ratio of odds is equal to 1, that means essentially that as we increase levels on our predictor variable, there's no change in the odds related to the target group membership. If the value is greater than 1, then we notice that there's an increase in the odds. So like with political interest right here, you can see the odds ratio is 2.4. So in other words, the odds, at one level on political interest, if we increment that level on political interest by 1, then we can multiply the odds at the previous level times 2.4, and that would give us the odds related to the odds of target group membership at the next level, our 1 unit increment on political interest. So that's sort of loosely how to think about it. So at any rate, you can see then as you're looking at our output here, you can see that essentially, this information is essentially reflecting the similar idea. This is just expressed in terms of log odds or changing log odds, and this is expressed in terms of changes in odds. So a negative value right here just reflects again that we have decreasing likelihood of falling into the target group as we increase in our on our predictor variable. And given that there are only 2 levels here, this makes it easy to say that males would be higher in terms of their likelihood of donating than females. And then given that this value is negative, less than 1, that's going to be consistent with our coefficient right here. A positive value for our coefficient will also be associated with an odds ratio that is greater than 1. So you can see that right here. So those are just a few things to look for. You'll notice that we have a confidence interval for the odds ratio. If we were essentially testing a non-directional null hypothesis, for the odds ratio, the null hypothesis is that it's equal to 1. So again, that's reflecting the idea that we don't have changing odds as a function of increases or decreases on our predictor variables. So if 1 falls between the lower and the upper bounds of the interval, then we would maintain the null and say that there's no relationship between the predictor and the essentially the likelihoods of falling into the target group. So you can see that's the case for gender and also for the dogmatism variable, but not for the political interest variable. Okay, so that gives you sort of a quick rundown of the first approach. You'll also notice that if you wanted to run something akin to a stepwise regression using logistic regression, you could certainly do that. If you go to method, enter, there are various approaches. So for instance, if I wanted to run a forward regression or a backward regression, the LR is the likelihood ratio test. That's probably the better bet. And just to kind of show you what it looks like, I just run it. And so you can see right here, forward stepwise likelihood ratio. You can see this is the first block right here. All of these, this is exactly the same as what we saw before in terms of how it's presented. All the values are the same. And you'll notice that essentially it looks like really only one predictor variable entered. If there were actually multiple variables included, let's do that. Let's take a quick look at adding in. Let's add in these 2 variables because I'm pretty sure that we will see a little bit different setup. So you can see right here we've got for the model right here, you can see we've got step 1, step 2, and step 3. And so in these cases, the steps are reflecting the addition of subsequent predictors at later steps. So this is kind of the original model. And so, all these values are exactly the same. Then we have step 2. And so this is the model chi-square. This is testing the model fit in relation to the null model. But this is actually testing the increase in fit as a result of adding in a predictor at step 2. And then the same basic logic goes for these two boxes here for step 3. So if we scroll down, you'll see we get the R-square, the pseudo R-square values for each of the 3 models. Hosmer-Lebesgue tests for each of those as well. The classification tables for each of those, you can see that really by kind of running this sort of stepping process, we don't really benefit a whole heck of a lot when it comes to looking at the classification results. Now, so if we look at the variables in the equation, step 1 just includes the political interest variable. That was the most significant, I guess you could say. Step 2, we added in external political efficacy, which was a significant predictor. And then step 3, we added in CFC on top of that. So, this is very much following the same logic as forward regression in the context of least squares regression. The last thing I want to note is that we could also run our analyses, our logistic regression analyses, through the generalized linear models option. So if we go there, we can move, you'll notice it says type of model, and we would want to, so we have all these different types of models that we could select. And this is a very flexible approach, particularly if you want to, let's say you wanted to run a Poisson regression or negative binomial or whatever. And so we're going to select binary logistic right here. Under response, we can move donate over to the dependent box. For predictors, I'm just going to go ahead and add them all just to do it. Move those down here. Now, if I happen to have, I said before that, gender we've added in as a covariate right here because we can still treat it as a scale variable so long as it's a dummy variable. But if it were the case that I happen to have another variable, like let's say party identification, where I had Republicans, Democrats, and Independents, I could include dummy variable versions of those dummy variables that incorporate the grouping information into the covariates box, or I could just move the general party identification variable over to the factors box and run it that way. We're not really doing that in this particular case, but I just want you to know that that is an option. If I click on model, and I'm going to highlight all of these are all main effects. I'm going to add those. And then if I go to statistics, I'll ask for exponential parameter estimates and click on OK. And so now you can see that I get, the generalized linear model is telling me what the dependent variable is and which group is the response in the reference category. So it's so in this case right here, one of the kind of the aggravating things about this particular generalized linear model is that it gives you a default in terms of how it treats the reference category and the target group, which is really kind of frustrating if you've sort of dummy coded your dependent variable. So under response, you'll see it says type of dependent variable, binary, reference category. What I'm going to do is I'm going to actually treat the first value as the reference category instead of the last value. So it defaults with the last value, and that's what's kind of aggravating here. So I'm going to rerun it now, and things should kind of line up a little bit more nicely and more consistently with what we had seen previously. So now you can see the procedure treats models 1 as the response category or the target category, 0 as the reference category. You'll notice that we have various goodness of fit statistics, but I'm going to key in on the omnibus test. This is the likelihood ratio chi-square testing whether this model is a significant improvement in fit over a null model with no predictors. And so you can see this is significant, indicating that yes, we have a significant improvement in fit. If I scroll down, you get a little test right here, which are walled chi-square test for each of the individual predictors. And it's largely going to sort of reproduce what you see down here in terms of the chi-square values and significance levels. Where this might be a little bit different is if you included a factor variable. But so if we look under parameter estimates, you can see gender, political interest, dogmatism, external efficacy, CFC. So you can see right here that gender, the relationship actually becomes positive. So in this case, females were a little bit more likely to indicate intention to donate than males while we're controlling for the other predictors, but that was still not significant. So really that's, gender is not really contributing to the model. When we look at political interests, there's a positive predictive relationship. It's statistically significant. Dogmatism actually was not significant as after we control for all the other predictor variables. External political efficacy, though, was significant. So basically people who felt more efficacious politically also tended to express a greater intention to donate. And then strangely enough, I haven't really figured out why, but folks who tended to express a greater consideration of future consequences actually expressed a lower likelihood of expressing an intention to vote, intention to donate. So that's kind of odd, and that predictor was significant. So this is a little bit counterintuitive right here, but this one was and this one were pretty much largely consistent with theoretical expectations. So that pretty much concludes this overview of binary logistic regression using the SPSS program. So hope you find this useful, and have a good day.